Hello everyone, October 8th. So we have implement try. It's I haven't done this before. Better start recycling problems hard. 208. I might or might not. I don't know. I mean, I've implemented try many times, so I don't think this will be too much a challenge. Uh, unless they have special requirements. Let's see if I've done it before. Yeah, I've done it August. Well, they are recycling problems from before, right? Okay. Oh, try. I cannot do it our way. I have to implement this way. Okay, that's fine. Store prefix. Yeah, it's a prefix tree. Initialize insert. Inserts the single string word into the try. Insert. And search, return true if a word is in the try. Starts with return true if there is a previous insert string. Okay? Yeah, I can just go right ahead and do it. And at a certain point, they keep doing this. I want to increase the number of questions I've done. So they keep doing this. I guess eventually we'll have to branch out, you know? It's like not like 2 questions a day. Like if it's something that we already done before, then we'll have to do another one that we have not done before. And otherwise, it's just it's missing my goal. Like I want to see the total number solved go up, but with this current scheme, it's not going to go up. It's not going to go up. Okay, so implement it here, but we're not going to test it. All right, initiate. We're gonna do object. Oh, but we can use defaultdict to do this. Let me see. This is a try, right? I'll get a new try, and then I'm going to insert, and I'm going to search. Search starts with search, which I think. This is how I used to do. So it's from collections import. I'm going to do defaultdict. So self dot try. Self dot root. Right? Is that what it is? Equals defaultdict. Hold on. Oh, I forgot how it is set up. It's a recursive. It's a recursive setup, right? Oof. What if we don't do it that way? I mean, this is the way it sets up is not how I would do it, right? Try, really what I think is you have a root, right? And then you insert from the root. We do need a root, but the root cannot be a try. The root will have to be like another structure. Wait, what is a defaultdict? So it's a defaultdict, right? And then we'll contain bunch of, we'll have the root, the defaultdict, right? And each one will be a letter, will be an initial letter, and that will be another root. So isn't that going to be? But then it's a self.root, right? That's Can I say something? I don't know. Like, is this a lambda and self.root? So like in default dict, everything is a self.root. So it's a recursive definition. right? And then when we insert, we say node equals self.root for a letter in word, right? What we do is we say node it's just a default. Is it just a default dict? I forgot. This is a very smart way to set it up. I forgot how it is done. So we say node letter is already. Oh, I think it's a node equals node letter because I already set up. It's also like a self-root. It's also the same thing, right? So we say. Oh, but self.root. I referred it here. Hold up. So what if we do this? Root equals this. That's a default, right? And then we say self.root equals root. Kind of avoiding referring self.root here, right? And then node equals this. Yeah. And then node equals to node letter because node letter is already another root, right? So we move on, we move until the end, and then we are done, right? Until the end, then we're done. All right, search node equals self.root. How do we know? We're gonna say root if it's in, right? So we say for letter in word, if letter in node, so node is default dict, then node equals node letter, and we keep going until if at a point that it's else, then we return false, right? And if everything, then we can return true. All right, starts with prefix, so node equals self.root. Isn't prefix is that the same? Starts with, it's just call. Oh, hold on, calling search. It's false because of the full word. It's a full word. Okay, so that's a full word search. Of course, if along the way something is wrong, we return false. And then we need to say, I mean, if I'd exhausted, so what happens is the letter has to exhaust and the node exhaust at the same time, right? So one of them will exhaust. If a letter in node, like if letter is too long, the word is too long, right? And I will exhaust the node, and eventually will hit a node. This will be the end node, and the new letter is not in, so we're gonna return false. Okay, that's fine. If a word is too small, right? If a word is too small, and then I do this, blah blah blah, and then we come out, and then we have to return this node equals this, right? And then if node, if not node, right, we can just return. How do we say that? Like say len node is larger. If len node is equal to 0, that means we have hit the final node, right? If not, it's gonna be returned true, right? So that's fine. And this one will be different. This one is not a search. So what we say is, let's do this one here. I think the prefix search, that's a true, right? That's prefix search. We just keep going. If anything is not matching, if it's too long, it's gonna be false. And once I exhaust the word, that's gonna return true. Now here, we're gonna say if, right? If self dot starts with word, which means if this one returns true, if this one returns false, right? If not, if this one returns false, then definitely, then we return false. If this one returns true, that means everything in the word can be found inside. And then we need to determine, oh, we can't. We cannot determine because I need to know the end node, which I don't have here. All right, so let's just not be that fancy. So let's just do this. All right, let's take a look. I think we only have one test case. Let's see. It's my understanding of this setup. Oh, that's not word, that's prefix. Wrong answer. Okay, so there's something wrong in my setup. Output true, false. Ooh, that was very wrong. The first one, I insert apple. All right, we can wait. Actually, I want to test this. So what's the? So this try. So try equals try, right? And then what we do is try to insert and all this, right? And insert. Let's print try dot root. Let's see. Let's see where we got wrong. And then I'm going to print every single one, right? Such iPod starts with an insert and this. Oh shoot, I shouldn't have these. And we're going to print try.root. Yeah, I still think it's what happened? Line 40. I got the wrong parentheses. All right. So default dict, I have a, and then we have a default dict. That is, they're all the same. Okay, that's not right. In this case, we just, because it has to be a default dict, so we just call it default dict, right? It's fine. Like root is going to default dict, and inside is going to be another default dict, but I don't say what it's going to be, which is fine, right? How do we recursively set this up? All right, I'm not going to recursively set up. This one I have to check. I don't know. So safest option, right? Safest option. So insert root is for the, and then we're going to say no letter. So it's a default dict of what? If you do this, you don't need a default dict. All right? You don't need a default dict. I just need a default dict of default dict. I think it's fine. So we'll just go lambda default dict, right? So we can just say node letter. So it's going to be default dict equals what? Equals, that is a node. Huh. I got confused by default dict. root is a default dict of default dict, right? And node letter is going to be a default dict of default dict. I still feel like there gotta be a way. Copy it. Or maybe it's copy it. Can we do copy? So is it from copy or import? Is it deep copy? I was worried about this later. Default dict kind of gave me trouble. Dictionary. That's it. Easy. So we're gonna say node letter equals a dictionary, right? Node letter equals, and then node equals node letter. And then for this, for letter in, the rest should be fine. Yeah, now we have this. But I don't think it's, the last one should be false. I'm inserting app, right? So we search for apple is true, search for app is false. Start with app is true, and then I insert again app, and I search app. I insert app, then I search for app, shall return true. Oh yeah, it is true. So it should be true, false, true, true. Let's try this one. Yeah, but I know there gotta be a way to, I remember, right? Yeah, basically saying insert app is not going to change anything. But we also deleted apple, which means, I think that is actually wrong. Like we insert and we search, and we're gonna let's say we search again, right? We search again, and then we're gonna search for apple. That shall be true, but I think my code will return false. What the hell? Oh, I forgot. Yeah, this one will be false because, yep, the last one shall be true. I see. App, alright. There's gotta be another thing. So it's going to be like the end indicator, right? The end of the word indicator. So we say only lowercase English letters. So we're gonna have a sentinel, right? Have a sentinel. We just go blah 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 at the end. So node pound, right? Node pound. Node pound. Aren't you supposed to have pound at every single time, right? Yeah, so no letter equals this. No pound. Hold on. If I have letters already in it, right? If letters already in it, then we just go. Okay, so here's what happens. So node, if letter in node, then if letter not in node, then we do this, right? Boom, boom, equals false. That's just an indicator whether this is the end of the word, right? And then we go blah 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 blah, and at the end, node pound is the node letter is going to, this is the next node, and then is the current is false. Now we go to the next one, and letter is not. If letter is in, then that means we have already set it, right? Now we'll go to the next one. If it's not in, that means it's a new node, right? Not a new node. That means the letter needs to be created. So I create a new node. The current will be false. Root. This is going to be false, right? So we need to create a new one with false. There you go. So the next letter, and then blah 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 blah, and at the end, this is the next letter, right? This is the next letter, and then we go to the next letter. If we're done, so this one will be true, right? Now in this case, when we search is for the whole word. So blah 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 blah. When we just check, right? When the return node pound, right? Node pound, and then starts with, we just go like this, and we're basically going to say search for apple. So it would be true, true, false, true, 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 right? True, false, true, true, true. So in this case, we can see it starts with this A. We have coming up, false, P, false, P is true. So we have a word ending here, right? And then L, false. Yeah, this one shall be right. We have more test cases. Let's just try one more time. Yep. Submit it. Pending. Yep. It's correct. So, man, we have done this. I've solved this problem before. Initially, I was trying to use a smart way to set up the trie nodes, but using default dict seems to be problematic. I don't know why it would be problematic. I mean, basically, this is a node, right? We just rename, yeah. So it turns out, using a vanilla dictionary is good enough. It's good enough and pretty easy to implement, right? The one important trick is to set up a sentinel, right? Sentinel to indicate the end of a word. In the current implementation, we use pound to signal that the current we set pound true to signal that the current node is represents the end of a word, and that's pretty much it. Alright, so we went at 128. Oh, this gives 93. Alright, so I'm curious. So I'm going to first check this, see what I did in the past. So I think this is the first solution I submit in the past. 1 year and 2 months ago. So I was setting up a separate node insert, node, end of word, right? We have end of word, and return end of word, yes, and prefix equals node dot prefix. Okay, that's fine. I think this one is 24. I still link and this. Node.link. That's cool. And then blah blah blah. Return node as a word. Oh, that's exactly the same, right? That's exactly the same. But we currently, instead of using the separate node, we use dictionary to handle this, which is fine. I don't think there's too much to do. What's this? Oh, I have solution. Spell checker. IP routing. Predicts text. Solving a word puzzle. Oh, wow. They put some effort into doing this. Is end. Try node. Try node. Insertion. So this is a try node, right? And in private, I can create links, okay, which is within try node. So it's like I'm using the type that I'm defining as well. Final integer R. Where do we use R? I don't think you use. Oh, this is R. Oh, that's the link. So public is try node. Links equals new try node. So 26. So the links contain 26 try nodes. And these are all private values. This is public. So this is a constructor, right? This is a constructor. Yeah, I forgot about Java. Almost complete. This is a constructor. And then when you say boolean contains key, and return links. This is not null. Okay. Get a try node. I see. Put char, so links this equals node. Set end is end. Oh, this is the try node. I see. Do have to set up a separate one for this. This is the try node. So each try node contains links, and each try node contains these functions. We have this, get is a getter try node. Put is put a node, right, in with a char into the links. So when we do this, insert new try node, and then we have current char. If it's node dot contains key, it doesn't contain key, when I put this with a new try node, and node equals to, okay, yep. Search. Nothing more to say. Search is pretty simple, straightforward. Have search prefix. Search prefix gives me a node, right? So I can just say search this. If node is not null and node is end. Okay. Search prefix. We simply say this. They can be combined together. We can just, let's say, just do another function, right? So it's going to be underscore search prefix, right? Self and prefix. This one I'm going to return a dictionary. This one I'm going to return. So it's going to return dictionary. Dictionary will be str and a dictionary, right? Well, it could be not yes. So we do this. Blah 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 blah, right? So the letter water and blah blah blah. If letter is in node and node equals node letter. What if we have a mismatch? If we have a mismatch, then it's not in. Then we should return none. Return just empty, right? Return empty. Otherwise, we're gonna return no. Like if we go to the end. So when we say starts with, we say node equals self dot search, right? Prefix. This will give me a node, and then if node is empty, then that's bad, right? Or if node is not empty, right? Node is not empty, then that means we are good. All right? Okay, so now word as a prefix. The prefix is very long, and then we'll have this, return this. Yeah, so we just return node. That's option, right? I think it's optional. Optional. So, because I want to do none. So, which is return node is not none. And then search node equals self dot search prefix word, right? And then we should return node is not none and node this. All right, try this again. Yep, I think this is a better one, better implementation. Update. Update. Following the official solution, we create a helper function called search prefix, which returns the last matching node, right? Last matching node if it exists, or none if there is a mismatch. Then we can use search prefix, right? Search prefix to handle search, and search starts with and starts with more easily. Right. All right. Do this one as well. And code. Yep. Let's try this one. Yep. All right. That will be it for today. It's not hard. It's good to refresh the memory. Yeah, I think I will just stick with this. This is easier to handle, right? This is easier than the default dict trick. I don't remember the default dict trick. Somebody must have a default dict trick. Default dict try node. Nah. That's not the one that I remember. Nah. But what's the Oh. Using default dict. Now I have to. They all say the try node. Yeah. There's no hope. There's no hope. I will just use the dictionary. All right, that'll be it. I'll see you guys tomorrow.